Alright, so we're getting stuck into a review on derivatives. I'm going to jump through like 8 examples. We're going to start really, really simple, and then we're going to get to some really, really complicated ones. Alright, so a basic polynomial here. The derivative of y with respect to x is going to be equal to, take the power multiplied by 5, so 6 times 5 is 30, x, decrease the power by 1, so now that 6 becomes a 5. Alright, this one's slightly different, or not really because it's got this fraction here, but you could rewrite 7x to the 4 on 2 as 7 on 2 x to the 4. That's the same thing. So you're just taking 4 and multiplying it by 7 on 2. Or you can just take the 4 and multiply it by 7, which gives us 28 x to the decrease the power by 1 over 2. And 28 divided by 2 we can simplify. 28 divided by 2 is 14. The x, that always tricks people up. The derivative of x, that's x to the power of 1. The 1 comes out the front. The power decreases by 1, which becomes x to the 0, and anything raised to the power of 0 is 1. So you get 1 times 1, which is 1. And then constants vanish. So the 2 disappears when we take the derivative. So a second example here, y equals 7 on x to the power of 5. You cannot operate on a variable on the bottom of a fraction. You have to move it to the top. And you do it using negative indices. So I'm going to rewrite this as 7x, and that x, when it comes to the top, x to the 5 becomes x to the negative 5. And so you can move powers to from the top to the bottom of fractions just by changing the sign on the power. Now the derivative of that, I'm going to use y dash this time. Negative 5 times 7 is negative 35. X to the power decreases by 1, so negative 5 becomes negative 6. Don't stop there. That's right, but it's polite to put things the way you found them. And this one had a positive index. So y dash will be equal to negative 35. And that x to the negative 6, we can move it back down. And it becomes x to the positive 6. Alright, so here we have y equals the 5th root of x squared. You can't operate with surds or with radical signs. You've got to turn it into a power. So we can rewrite that as x. Now whatever x is raised to the power of, that's going to be the top of my fractional index, and that whatever the root is, in this case the 5th root, becomes the bottom. So y equals the 5th root of x squared is the same as y equals x to the power of 2 over 5. And then you just apply all of your rules, but it can get a little bit confusing. Y dash equals the power comes out the front, so 2/5 comes out the front, and then you decrease the power by 1. You can do it on your calculator. 2/5 minus 1 is negative 3/5. Alright, so 2/5 x to the negative 3/5. I'm just going to use a different pen, that's annoying. Maybe a different one again. Okay, so y dash equals, now that negative power is annoying to me, so I'm going to move it to the bottom of the fraction. X to the positive 3/5. And then I'm going to rewrite it as a radical because they gave it to me as a radical in the beginning. So 2/5 times, now the thing on the numerator is the power, so x to the power of 3, and the thing on the bottom is the root. Alright, so be careful here. The small 5 is the 5th root, the large 5 is 5 times all of that. Alright, so a bit complicated. Alright, so mixing it up here, y equals 1 on x plus 1 on root x. Rewrite it, the x's all need to move to the top. So it's going to be y equals x to the negative 1 plus, that's x to the half, so it's going to be x to the negative 1/2. Alright, power decreases by 1, that negative comes out the front, so it's negative 1, which I don't have to write the 1, I could just write negative x to the negative 2 plus, decreasing it by 1, it's going to be plus negative a half, which is minus a half, minus 1/2 x to the negative 3 on 2. Alright, negative power, so that's got to move to the bottom. It's going to be negative 1 over x squared minus 1 over x. So I'm moving that negative 3 on 2 to the bottom to become x to the power of 3 on 2. But then I also need to turn it back into a radical. So negative 1 on x squared minus 1 on the square root of x cubed. The cubed comes from the top. The 2, the square root, comes from there. Getting trickier and trickier. Alright, so this is the last one. I've cleared some space because it is a bit complicated. X plus the square root of x over x squared. If you knew the quotient rule, you could use the quotient rule here. But I'm going to assume you don't know the quotient rule. So I can rewrite this as y equals, and I can move that x squared to the top, which is going to be x squared bracket, oh sorry, not x squared, it's x to the negative 2, because I've moved it to the top of the fraction, times all of that stuff on the top. And no point writing it as a square, as a square root, let's write it instead as a fraction. Okay, now, expanding using the distributive law. So x to the negative 2 times x to the 1 is the same as x to the negative 2 plus 1. So it's going to be x to the negative 1. And then x to the negative 2 times x to the half. You've got to add the powers together if you're multiplying two things with the same power. So x to the negative 2 plus 1/2 is negative 3 on 2, negative 1.5. Alright, x to the negative, I'm still looking at y equals here. So now I find the derivative of that. So it's going to be negative x to the negative 2 plus, minus 3 on 2, x, decrease that by 1, negative 5 on 2. Okay, moving all of our, making some positive indexes, I suppose. It's negative 1 over x squared. That plus minus just becomes a minus. Minus 3, 2, x. It's going to be to the power of 5 square root. Okay, just make some space for that. 2 square root x to the 5. Alright, I'm pretty happy with that. That's a review of derivatives.